All right, so here I'm going to do a presentation on the physics of topspin on tennis balls for physics 139. So I'm going to go over what it is, how it relates to our class, how is topspin created, the Magnus effect, which has to do about the force when it's in the air, basically. How does the topspin affect the ball when it bounces? What happens after the ball bounces? And why do players like to hit with topspin? Why do they have to hit with topspin, basically? And some analysis and calculations. Then I'll do a summary and then show my sources. What is topspin? It's basically a type of spin in which the ball is moving forward like this while having forward spin. So, yep. Players have been hitting with more and more topspin over the past few decades because it's seen that it's just more optimal. It's better for them. The people win more, I guess, when they hit with topspin. Here we have Rafael Nadal. He hits with 3,200 revolutions per minute for each forehand he hits. This is like the most in tennis, and that's like a lot of the inspiration, I guess. I'm gonna speed it up a little because right now it's super slow. As you can see, he angles his racket down, he hits it, and then it spins forward on the way this way. So, and then as you can see from the ball here, same concept, spinning forward while going forward. So, how does this relate to our class? So, a lot of the concepts within our class from kinematics, forces, energy all apply here. So, the ball being hit is basically a projectile, except there's, other force being added on it. It's not just gravity and the pulling it down. There's more pulling it down, I guess. There's also forces from when the ball is actually hit. Springs, friction, springs because the ball is basically a spring and it compresses. Air resistance is present as well. However, it's negligible. In our class and in this presentation as well. All three of Newton's laws are applicable, and that's just because inertia, right? The ball's able to move because we actually hit it. Force equals mass times acceleration. I think that's pretty explainable. Also Newton's third law, which we'll see in the Magnus effect later. So here I'm going to go over how topspin created, and it's basically just by the friction. And in summary, the friction basically just grabs the ball and it pulls it forward, but it also creates a forward spin on it. So here, I'm going to use this diagram on the left to explain it because it's pretty simple. It's the simplest way, I think. So the blue is the racket, the yellow is the ball, the green is the normal force that the racket applies on the ball. The red is the friction, and then the top arrow is the way the racket's moving, and the bottom black arrow is the way that the ball actually ends up going. So like I said, there's a force being applied from the normal force that goes this way, right? But the friction and the way that the racket is being hit makes it kind of counteracts it. And that's why the ball ends up getting grabbed. It gets this kind of spin and it ends up going that way. And then when you add all the forces together, you get this bottom black arrow. So the Magnus effect is basically a natural phenomenon, not only in tennis, but in this case, basically it's going to drop the ball down faster. So yeah. So basically, I'm just going to use this diagram on the left to explain it. Basically, what happens is that there's an upward force from air resistance because of the way the ball spins. There's an upward force, and like Newton's third law says, every force that's there needs to be an equal force on the object that's applying the force. So that's why the ball ends up going down. It's not exactly vertically down, but it's pretty much the same almost. But yeah. How does topspin affect the ball at the point of the bounce? So there'll be less friction on the topspin ball, and that's just because you can almost imagine that a topspin ball is like has more movement than a flat ball that's moving, and that's just because of the spin, right? So because of that, we can use our equation for the kinetic coefficient of friction, and we can solve and find out that uh kinetic coefficient of friction will be less for a topspin ball than a flat ball, and then the way I should down here in these fractions is that a flat ball kinetic coefficient of friction would be a larger number over a smaller number, while the topspin ball kinetic coefficient of friction would be a smaller number over a larger number. Hence, it would create a smaller kinetic coefficient of friction overall. What happens after the ball bounces? So the ball will have a higher velocity after it bounces because there's less friction. So the friction basically is slowing down the ball less. It has not the same horizontal velocity, but it'll have still have fast horizontal velocity, like you could say. That's just because the ball, when it bounces, it kind of acts like it's gonna act like the spin is gonna act like an engine that's just like kind of propels it forward almost. It's not an engine, but kind of like that. A topspin ball will bounce higher as well than a flat ball, and as you can see, in the diagram here. That's how it works. And that's just because since the ball is being pulled down more abruptly, it's gonna have to bounce higher than if it was just being constantly only pulling down by gravity. Once again, it's being pulled down not only by gravity, but the Magnus effect as well. So that's why. And then Hooke's law is applicable here as well. And that's just because, I mean, like I said before, a ball, it has the same concept as a spring because it can compress. So yeah, we can probably calculate for those the three components of Hooke's law as well here. Here I show two of the world number ones, the men's and the women's. Here we have Alcaraz and Iga. So you can see the way that they're hitting the ball is like they're angling the racket down and they're almost holding it in an uncomfortable position like this almost, in a way that they can basically just have their hand naturally there to put spin on the ball when they hit the ball forward. So the reason why they hit like this is because it allows higher net clearance. Because like I said, the ball's going to be pulled on faster, so you can hit the ball higher and not have it, not worry about it being out, like out farther later. It'll just be pulled down and hit pretty deep. It's also a good way to attack because, like I said, the balls are going to be faster and bounce higher. This is going to create like unnatural positions for people to hit it in. So yeah, that's why they like it. Here's some analysis. I'm not going to go over the whole thing, but as you can see, the topspin forehand, it just has higher overall velocity than the flat forehand. I mean, because this guy's just hitting it. The same guy's hitting it, it's the same ball. Also, the flat forehand versus the topspin forehand in terms of force, joules, and watts. You can see that it's basically just it's always going to have more force applied on the topspin forehand, more work done, more power. And that's why when people say someone hits with heavy topspin, what they're basically just saying is that the force on their ball is stronger than if they were to just hit it flat. And you can see we use the equations here, right? We just use force equals ma here, kinetic energy 1/2 mv squared, as well as power, which is just kinetic energy divided by time, work divided by time, basically what we got here. The summary: topspin is forward rotation on a ball that goes forward. It involves concepts of kinematics, force, and work energy, which is why it's relevant to our class. It is created by friction, which grabs the ball. In fact, people have been creating strings and rackets that can grip the ball more, basically, so it creates more friction, so it can go more spin. The Magnus effect is also the effect that's basically pulling it down more, as well as gravity. There's less friction when the ball bounces. This makes it bounce farther and higher, and that's like we said, I already covered that. It allows just for more consistency, which is why I said players like to use it. It also can generate an attack or be a good use of defense just to get the ball back and not have them be able to attack you, I guess, even further. And here are my sources that I use for this. So, yeah.